Hello, today we're looking at motion on a straight line. Okay, so let's see what this means. All right, so given the following position function for a particle at time t, find the velocity and acceleration of the particle at the given times. Okay, so what we need to know in order to answer this question is the relationship between, let me move that, the relationship between the position function and the velocity and acceleration. So if we take the derivative, the first derivative of the position function, we end up with the velocity. Now if we take the second derivative of the position, or the first derivative of the velocity, we end up with the acceleration. All right, so now that we know that relationship, we can answer this question. All right, so let's do that. So let's start taking the derivative. So s prime equals negative 27t squared plus 2 minus 2t. Okay, and that's our velocity at time t, our particle. The second derivative equals, let's see, negative 27 times 2, which is negative 54 t minus 2. And this is also the first derivative of the velocity, and this is our acceleration. Great. So now they're asking us to find, what are they asking us to find? To find the velocity and acceleration of the particle at the given time. So it doesn't look like we're given a time. Okay, that's interesting. So let's add one in. Okay, so it looks like the time is missing. So let's suppose we want to find the acceleration velocity at time t equals, I don't know, 3 seconds. So this means we need to plug in 3 for our t in the velocity expression, or the first derivative of the particle. So that's negative 27 times 3 squared plus 2 minus 2 times 3. Okay, so let's evaluate this. 27 times 9 plus 2 minus 6. Let's figure that out. 27 times 9. That's negative 243 minus 4. That gives us negative 247. Okay, so we need some units here for speed or velocity. Let's go with meters per second. So let's assume that s function is in meters. Okay. All right, so that's our velocity. Now let's figure out what our acceleration is. So there's our acceleration. So our acceleration is the second derivative evaluated at that time t equals 3 seconds. That's negative 54 times 3 minus 2. All right, let's see what that is. 54 times 3. That's a big number. Negative 162 minus 2. That gives us negative 164, and that's meters per second square. So these are the units of our acceleration. So this is our acceleration at time t equals 3. This is our velocity, whoops, at times t equals 3. Good, and we're done. All right, so that brings us to the end. Wow, all the way down here. So if you have any questions, send us a note at info@raisemymarks.com or give us a call day or evening, and we'll be happy to answer your questions. Thank you for watching.